Welcome back. Mr. Sutton bringing you the second of two lessons on surface area. In this one, we'll tackle pyramids, cones, and spheres as well. Basically, surface area and lateral surface area of solids with one or no bases. Real life problem, we'll take a look how much material is needed to make an ice pyramid. Let's begin by talking about pyramid surface area. So there is a surface area formula on the MCAS formula sheet for square pyramids, but not hexagonal pyramids and any other kind of pyramid. Let's do a general formula first here. So one measurement that we need to take into account with pyramids is something called the slant height. That's this height right here that runs from the base of one of these triangles to the top. And it's always going to be in the center of the triangle because this is actually an altitude on a triangle. We also have a regular height and a base area. Deconstructing this pyramid, we've got 6 of these triangular faces, although it could be any number of triangles for any kind of pyramid. We also have that base, which could be any kind of shape. So to find the lateral surface area, we need the area of all these triangles added together. Well, we need all the bases. Those all add up to the perimeter of the shape. That's just the distance around the base. We also need to know the heights of these triangles, which happens to be this slant height here. So we could figure out the area of one of these triangles by doing 1/2 the little piece of the perimeter here times the slant height. To get the area of all the triangles, we can just do 1/2 times all of these bases, the perimeter times the slant height. So 1/2 perimeter times slant height, that's lateral surface area. If you want total surface area, you just have to add this little piece to the area of the base. And now to find the slant height, generally if you have the height and the distance from the center to the end here, you can use the Pythagorean theorem to find the slant height. Let's do an example where we find the surface area of a pyramid. And this is not a square pyramid, so the MCAS formula will not help us at all here. We need to use our more general base plus 1/2 PL kind of formula. So first let's find the area of the base. Pause the video and see if you can do that. So the base, that's just this triangle down here. So that's going to be 1/2 5 times 4.3. And I'll use the calculator for this. So 1/2 times 5 times 0.3 comes out to, or 4.3 comes out to 10.75. Next, we need the perimeter. So we have 5 this way, 5 this way, 5 this way. Oh, so that just adds up to 15. And we also need the slant height. That's the height of all the individual triangular faces. So that's just this piece here, this 7.1. Putting all this together, we've got 2.75 plus 15, 1/2 rather, times 15 times 7.1. Use the calculator for this. And all of that happiness is going to come out to, exactly 64. Man, maybe we could have done it without a calculator. Oh well. And that'll be square centimeters. Let's do another pyramid problem. In this one, a cold weather theme park wants to create a square ice pyramid exhibit with the following dimensions. So 20 meters on a side and 24 meters tall. How many square meters of ice bricks will be needed to make this happen? So presumably we don't really care about the floor of the pyramid because no one's going to see inside the pyramid anyway. If we just want the outside here, then we're just looking for the lateral surface area, which is going to be 1/2 perimeter times slant height. The perimeter for this, since it's a square pyramid, you've got 4 of these 20-meter sides, so that's just 4 times 20, or 80 meters. For the slant height, again, that's the distance from the top to the middle of one of the sides down here. Now, we could figure this out given the height if we also had the distance from the center to this outside, because then we would have a right triangle and we could use the Pythagorean theorem. Well, it's halfway across the pyramid to go from the center to the side, so that's 10 meters. So we have the square root of 10 squared plus 24 squared, and I'll use the calculator for this. So plugging that in and square rooting it, we've got 26. So then we've got 1/2 80 times 26, and I'll use the calculator again. So 0.5 times 80 times 26 comes out to 1,040, and that'll be square meters. Now, for square pyramids, there is a special formula we can use, and this one's actually on the MCAS formula sheet. If you think about the perimeter, it's always going to be 4s for a square pyramid, where s is one of your sides. Well, what's 1/2 of 4s? Oh, 2s. So we could just kind of shorten this and go the 2SL route for figuring out lateral surface area of a square pyramid. And then if you want the total surface area, you just need the 2SL plus s squared, the area of the base. At this point, we're going to switch to cones and other curvy shapes. We want to find the lateral area and surface area of this cone here. Now, in general, we can say lateral area, again, is 1/2 perimeter times slant height. This is kind of like a pyramid, only with a curved base. So instead of perimeter, we could use circumference. So 1/2 2 pi RL. But why write all this out, right? I mean, 1/2 and 2 are just going to cancel. So this is where the MCAS formula for pi RL comes from for the lateral surface area of a cone. So we've got pi times the radius. Pause the video and plug in the appropriate values here. All right, let's see how you did. So we have pi times our radius of 6. And for the slant height, oops, we're not quite there yet. We've got the height, but not the slant height. So we need to do the square root of 6 squared plus 8 squared, which is going to be 36 and 64. 100 square root is going to be 10. You also might have seen that this was a 3, 4, 5 triangle, but if you didn't, there's the Pythagorean theorem. So we've got pi times 6 times 10. So that's 60 pi, which, if I plug it into the calculator, comes out to 188.5, and that'll be square meters. Now, for total surface area, we have our lateral surface area, pi RL, plus the area of that circular base, which is pi r squared. So there's the MCAS formula for surface area of a cone. So we're going to have pi times 6 squared plus the lateral surface area. So that's 36 pi and 60 pi, or 96 pi. And that's all going to come out to 301.6 square meters. Now, the reason I talked about it in terms of how many pi's we have, every now and then on the MCAS or some other tests, they'll ask you to leave things in terms of pi. So you should be prepared to give your answer in either format. We're going to do another real-life application now. In a sport called sphering, a person rolls down a hill inside an inflatable ball surrounded by another ball. Seems like a horrible idea. The diameter of the outer ball is 12 feet. Find the surface area. So we're going to start off, I'm just going to give you the surface area formula for a sphere. If you want, we're going to prove it a little bit later on in this lesson. So that formula for now is 4 pi r squared. And this is just the only surface area formula. There's no lateral surface area of a sphere because it doesn't have any bases. It's just one large surface. So given that formula, go ahead now and figure out the surface area of this sphere. All right, so all we need to find for this is the radius. If we have a diameter of 12 feet, the radius is going to be half that, so 6. So we need 4 pi times 6 squared. And plug in all that in the calculator. I come up with 452.4, and that'll be square feet. For this next example, we're going to put it all together, literally. This is finding compound surface area. We want the surface area of this shape to the nearest hundredth, and you'll notice this isn't just one, but actually two shapes kind of smushed together. So we have a cone for the lower part and a hemisphere for the top part. Pause the video and see how far you can get with finding the total surface area for this thing. Alright, so the best way to do this one, I think, is to split this problem up into two parts. So let's talk about the cone first. Now, we just need the lateral surface area of the cone, since the top base here is kind of buried under the hemisphere and isn't on the surface anymore. So finding lateral area for a cone, we're going to need the slant height. So we need the square root of 4.9 squared plus 12.6 squared. And that's going to come out to about 13.52. So we need pi RL. Again, that's our lateral surface area formula for a cone. So pi times 4.9 times 13.52. Calculator time again. And the result from all that is about 208.12. So that's square centimeters. But we're not quite there yet. we also need to figure out the surface area of the hemisphere. Well, we know the surface area formula for just a regular sphere. Again, that's 4 pi r squared. So a hemisphere is going to be half of that, which is to say 2 pi r squared. We already know the radius, so we just have to plug that in. So 2 pi times 4.9 squared comes out to 150.86. And now we just have to add those two surface areas together. And let's tally up that result on the calculator. Although we might not need a calculator for this. This is just going to be 358.98. Got it. And that's centimeters squared. We're going to wrap this up with kind of an intuitive proof of the sphere surface area formula. Now, this proof relies on you accepting the fact that a sphere has the same surface area as a cylinder of the same height. So, for example, if we have a sphere here and we unfold it, we should be able to make a cylinder with the same height as the total diameter of the sphere. Now, we know that the lateral surface area of the cylinder, which is all our sphere area here, is 2 pi r times the height of the cylinder. But the height of the cylinder, we just said that's the diameter of the sphere. So in terms of the sphere's radius, that height should really just be 2 times r. Well, hold on a sec. That means that the sphere's surface area is going to be 2 pi r times 2r, which, if you multiply things together, that's going to be 4 pi r squared. So that's all we have for now. Until next time, this is Mr. Sutton signing off.